In this video, we are going to discuss prime factorizations, and we'll find them using factor trees. And we're also going to talk about least common multiples. And the importance of talking about the least common multiples prior to adding and subtracting fractions is that we're going to use this process to find a least common denominator. So this will be important for the next couple of lessons. So first, let's go over a little bit of terminology. So factors are two things that are multiplied together. So a times b, for that expression, both a and b are called factors. If a times b is equal to m, and both a and b are integers, then a and b are called factors of m. So whatever they multiply together to get, they're factors of that number. A prime number is a counting number greater than 1 whose only factors are 1 and itself. And you can see in the chart, all the ones that say prime only have two factors, 1 times the number itself. The composite numbers, on the other hand, have a factor other than 1 and itself. So you can see here the first composite number we see is 4. And that's because it also has the factor of 2, because 2 times 2 is 4. So that's the difference between a prime and a composite number. You know it's a prime number if you can only, the only two factors are 1 and itself. So a prime factorization of a number is if you find the product of all prime numbers that equal that number. So that means you're going to have more than just two factors, more than likely. You might have a whole list of factors. The way you find those, and I think it's the easiest way, is to do a factor tree. So let's talk about a factor tree. To do a factor tree, you simply break the number into branches. Any two numbers that multiply to get that number. So 80, any two factors of 80. So I could use 8 times 10. I could also use 2 times 40 or 20 times 4 or any numbers that I know that multiply to get 80. You don't have to think too hard. The first two numbers that you think of that work, use those two numbers. Okay, so once I use the number, I cross it off and I continue to split the numbers apart until they're prime numbers. So 8 can be divided by 2, so 2 times 4. Now 2 can only be divided into 2 times 1. The only factors of 2 are 1 and 2, if I'm looking at whole numbers. So 2 is prime. So I'm done with that branch. Next, I'm going to look at the 4. 4 can be broken down into 2 times 2. I've used the 4, so I cross it off. And then I've got branches of 2's. 2's are prime, so I'm done with those branches. Now I've still got a 10. So 10 can be broken up into 2 times 5. 10 is done. 2 is prime, because all we can do is break that down into 2 times 1. And 5 is also prime, because the only two factors of 5 are 1 and 5. So notice everything is either crossed out or highlighted. That means my tree is done. All of the circled or highlighted numbers are the prime numbers that multiply together to get 80. So if I wanted to write down the prime factorization of 80, it would be 4 2's, so 2 times 2 times 2 times 2, and then times 1 5. So that's the prime factorization of 80. Let me quickly demonstrate if I had picked different numbers. So let's say when you did yours, you didn't pick 8 and 10. You picked 2 and 40. So we used 80. Notice that 2 is already prime, so that branch is done. But I can break down 40. Let's say you did that by 4. So 4 times 10. So 40 is used. 4 can be broken down into 2 times 2. 4 is used. 2 and 2 are prime. So those branches are done. And then 10 can be broken down into 2 and 5. So 10 is used. 2 and 5 are prime. Notice that I got the same result. So even though I started my tree with a 2 and 40 instead of 8 and 10, at the end I still get 4 2s and a 5. So it doesn't matter which factors you use. Your tree may look a little different, but at the end all of your prime numbers will be the same. Okay, so I encourage you to pause the video, try 2, 3, and 4 on your own, and see what you get for the prime factorization using the factor tree method, and then check your answers with a video afterwards. So for number 2, we're doing the prime factorization of 48. So we're going to do the factor tree. So 48 is 2 times 24. 2 is prime, so that one's done. 24 could be 6 and 4, so I used 24. 6 can be broken down into 2 times 3, so 6 is done. And 2 is prime, and 3 is also prime, because I can't break those down any further than the number in it, and 1, right? So 4 can be broken down into 2 times 2, and again, 2 is prime. Notice that all the numbers are either highlighted or crossed off, and all the highlighted numbers are prime numbers. So that lets me know that I'm done. And now I just give a list of all the prime numbers. So I have 4 2s and 1 3. So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Remember that if you wanted to check your answer, you could just multiply all these factors together and you should end up with the original number. If you multiply them all together and you don't get the original number, then a mistake happened at some point and you should retry your factor tree. All right, number 3, 252. So it's even, so it's got to be divisible by 2. I don't know what it is off the top of my head, so I'm going to use my calculator. I got 126. All right, so 2 is prime. I've used 252. 126 is also even, so I'm going to go ahead and divide that by 2. So 2 times 63. So I've used 126. 2 is prime. 63 can be broken down into 7 times 9. So then 7 is prime. So that branch is done because I can only break 7 down into 1 times 7. And 9 I can break down into 3 times 3. And then the 3's are prime. So I've finally ended all my branches. I have all prime numbers at the end. So let's see, I've got 2 2s. So 2 times 2. I have 2 3s, 3 times 3, and I have a 7. So the prime factorization of 252 is 2 times 2 times 3 times 3 times 7. All right, 126. Well, actually, we just did 126 right here. So in the previous problem, we've got the factor tree for 126. So 2 times 63, 9 times 7, 3 times 3, and then all of these are my prime numbers. So my prime factorization of 126 is 2 times 3 times 3 times 7. So that brings us to least common multiple. The least common multiple of two numbers is the smallest number that is a multiple of both numbers. So the way you can find the LCM using prime factorization is as follows. So you use a factor tree to find the prime factorization of each number. You're going to list the primes just like we did above, and then the LCM will include each different number or each different factor. If a factor appears more than once in one or more factor trees, Include the factor the higher number of times it appears. Okay, that sounds confusing, but let's look at this example. So 36 and 120 are the two numbers that we're looking at. So 36, so somebody did a factor tree and got the prime factorization 2 times 2 times 3 times 3. And then we're also looking at 120. So someone did the prime factorization for that and got 2 times 2 times 2 times 3 times 5. So both lists have 2's. The first list has 2 2's and the second list has 3 2's. You're going to use the most 2's that appear in any list. So you're not going to add them together. You're not going to use 5 2's. You're either going to use 2 2's or 3 2's. You're going to use the most. So you're going to use these 3 2's, and these are considered repeats. So we don't use those. So you'll notice that we have 3 2's over here listed for our LCM. Our LCM kind of goes to the next line, so I'm going to cross it out and write it up here. So they're all next to each other. Okay, so then in 36, you see the next two factors that are listed are both 3's. So there's 2 3's here. And in the 120, there's only 1 3. So we have to include 3, but we want to include the most that appears in any list. So since there are 2 3's over here, we're going to use 2 3's in our LCM. And this other 3 that's by itself is considered a repeat. Notice that we've come to the end of the list for 36. So now we're going to look at 120. And there is another number here. There's a 5. We have to include every different factor or every different number that appears. So we include the 5 over here. So it doesn't have to appear on both lists. If it appears anywhere on either list, it has to be included in our LCM. If it is repeated on both lists, then you include the most, whichever one occurs the most. So in other words, if there's 2 in the first and 3 in the second, you would include 3 in the LCM. Okay, so once you find your list for the LCM, you multiply all the numbers together. And for this example, you would see that you would get 360. So let's try some of these. So for number 1, we want to find the LCM of the pair of numbers. So for 24, our factor tree could be 2 times 12. 2 is prime. 12 can break down into 4 times 3. 3 is prime. 4 can break down into 2 times 2. And the 2's are prime. So we've reached the end of all the branches. So 24, our list is, 3 2's, so 2 times 2 times 2 times 3. And now we're going to do the same thing for 36. So it's important to make 2 lists. You make one list for each number, and then you compare them. So 36 I could break down into 6 times 6. 6 can break down into 2 times 3 for both 6's. And then 2 and 3 are both prime. So that's the end of that one. So I'm going to make my list of prime factors for 36. I have 2 2's and I have 2 3's. So now to find out what my LCM is, I'm going to include each different number or each different factor, and I'm going to include it the most times it appears in either list. So for 24, I have 3 2's. In 36, I only have 2 2's, so I need to include 3 2's in my LCM. For the factor 3, I have 1 3 on the top, and I have 2 3's on the bottom. So 2 3's, that's more. I'm not going to include the single 3, I'm going to include the double 3's. And so to find the LCM, I'm going to multiply that together. So 2 times 2 times 2 times 3 times 3, and hopefully you get 72. So the LCM here is 72. All right, so let's do it for number 2. We've got 28. So we could do 2 and 14. 2 is prime. 14 can be broken down into 2 times 7. And 2 is prime, and so is 7. So that one is done. So we'll have 28 equals 2 times 2 times 7. And now we're going to do the prime factor tree for 40. So that could be 4 and 10. 4 breaks down into 2 and 2. 2's are both prime. And then 10 breaks down into 2 and 5. And 2 and 5 are both prime. So we can make our list for 40. That would be 3 2's, so 2 times 2 times 2, and then times 5. So now we're ready to figure out our LCM. So the first factor is the factor of 2. So I'm definitely going to include 2. There are 2 in 28, but there are 3 in 40. So I need to include the most it appears. So that would be 3 2's. I also see a 5. That's only included in the 40, but that's okay. I have to include it. And then I see a 7. I need to include that. And now I've included everything, all the different factors, the most times that they appear in any list. And so now I need to multiply those together and see what I get. So 3 2's, a 5, and a 7. I got 280. So hopefully you did too. So our LCM is 280. All right, we've got 2 more examples. So if you haven't done so yet, you may want to consider pausing the video, trying these on your own, and then returning to check your answers. So for 55, this will be 11 and 5. And both of those numbers are prime. So that was a pretty quick factor tree. 88 is 11 and 8. 11 is prime. However, 8 is not. I can keep going with the 8. So 8 will be 4 times 2. 2 is prime. 4 is not. 4 is 2 times 2. And now I'm at the end for 88. So if I make my lists, I have 55 is 5 times 11. And 88, I've got 3 2's and an 11. So if I'm looking at my lists, let's make my LCM. I have 2's, 3 of them. So I've got to include 3 2's. I have a 5, so I've got to include 5. And then I have an 11. Now notice I have 1 11 in each list. You only include the factors from one list or the other. So since they're both it appears once in each list, I'm just going to include it once. All right, so we've got 2 times 2 times 2 times 5 times 11. When you do that, you should get 440. So the LCM is 440. All right, last one, number 4, 60. The factor tree, we could use 6 and 10. 6 could be broken down into 2 and 3. And 10 can be broken down into 2 and 5. 2, 3, and 5 are all prime. So that would be the end of that factor tree. For 72, we could do 9 and 8. 9 could be broken down into 3 and 3. And then 8, we've done it a couple times now. 4 and 2. 4 goes down to 2 and 2. And 3 and 2 are both prime. So all of my branches are done. So now I'm ready to make my list. So for 60, I have 2 2s, a 3, and a 5. For 72, I have 3 2s and 2 3s. Whoops, that looks like 33. Okay, so for my LCM, I am going to include each different factor. So I have 2s in both lists. In the top list, there are 2 2s, and in the bottom list, there are 3 2s. So I have to include the biggest number of factors. So 3 is bigger than 2. So I'm including the 3 2s, and the double 2s are not included. Then I see 3s. There's 1 3 in the top and 2 3s in the bottom. So I'm going to include the 2 3s and the 1 on the top not included. And then I see a 5. It's got to be included. Okay, so now that LCM will be multiplying all those numbers together, and it looks like we get 360.